Okay, so far we've looked at sketching quadratics when we're given the equation in turning point form. If we're not given the equation in turning point form, we've looked at 1, converting it to turning point form via completing the square and then sketching. Or 2, we've looked at finding the x coordinates first, which in the previous video we were able to do by factorising and using the null factor law, and then from there finding the equation of the turning point form. Of the turning point, sorry, not the equation of the turning point form, finding the coordinates of the turning point. So what we want to think about today is, okay, what if we've got the equation in expanded form, so ax squared plus bx plus c, so not turning point form. What if then when we try to find the x-intercepts, it's a quadratic that doesn't factorise, and so we then need to use the quadratic formula? Let's have a think about that. The other thing I want to identify here is that the quadratic formula also gives us quite a lot of bits of information about the graph. So we'll have a look at that as we work through this section of your notes. So remember, I've summarised our quadratic formula here. So remember, if we are solving a quadratic equation of this form, ax squared plus bx plus c equals 0, then the solutions to that equation are x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So example 1, we want to find the x-intercepts of each of the following. Okay, so finding the x-intercepts means letting y equal 0. We then have a quadratic equation to solve. And just like in the previous section, I wouldn't be using the quadratic formula unless I needed it. I'd be first trying to see whether I can do 2 times negative 3 is negative 6. Factors of negative 6 that add up to negative 4, they don't exist. It's going to be 1 and 6, negative 1 and 6, positive 1 and negative 6, negative 2 and 3, positive 2 and negative 3, and none of those are going to add up to 4. Okay, so we can't factorise. So if we can't factorise, then we use our quadratic formula. Alright, so we've got the rule up there. So x is going to be equal to negative b, which in this case is negative 4, plus or minus the square root of b squared, 4 squared, which is 16, minus 4 times a, which is 2, and times c, which is negative 3, all over 2a, so that's 2 times 2. So we've got negative 4 plus or minus the square root of 16, that's going to be plus because we've got minus minus there. 4 times 2 is 8 and times 3 is 24, all over 4. So we've got negative 4 plus or minus root 40 on 4. Simplifying the surd, 40 is 4 times 10, so the surd will simplify to 2 root 10 over 4. And then the fraction will simplify because there's a common factor of 2. Dividing the entire numerator by 2, we get negative 2 plus or minus root 10, and dividing the denominator by 2 over 2. So we've got 2 x-intercepts there, negative 2 plus root 10 over 2, and negative 2 minus root 10 over 2. Okay, let's think about b. So again, x-intercepts, we let y equal 0, and so we have this quadratic equation to solve. Okay, so we're in the standard form. We're going to see if we can factorise. 3 times 5 is 15, factors of 15 that add up to negative 6. They're either going to be 1 and 15, negative 1 and negative 15, 3 and 5, negative 3 and negative 5. None of them add up to negative 6, so it doesn't factorise. Okay, so we use quadratic formula. X equals negative b, which in this case will be positive 6, plus or minus the square root of negative 6 all squared. If you're going to write that out, please make sure you write negative 6 squared, not negative 6 squared. They don't mean the same thing. I wouldn't write it, I'd just do it. Negative 6 all squared is 36. Minus 4 times a, which is 3, and times c, which is 5, all over 2a, so 2 times 3. So we've got 6 plus or minus the square root of 36 minus 4 3s are 12, 12 times 5 is 60. Okay, so I'm already anticipating that we've got a problem here. 36 minus 60 is negative 24, and so that's an issue. Okay, you can't square root a negative, and so the equation has no solutions, which means that the graph has no x-intercepts. So we have no solutions to the equation, which means that the graph has no x-intercepts. Okay, so remember, what we've just discovered there is an issue with the discriminant. So remember the discriminant, b squared minus 4ac, is the bit underneath the square root. Remember the discriminant doesn't actually involve the square root. B squared minus 4ac, not square root of b squared minus 4ac, is the discriminant. Now, if the discriminant, b squared minus 4ac, is a positive number, like what happened in part A, then we're going to have plus minus square root of a positive number, which gives us two values, and so therefore the equation has two solutions. Then the equation has two solutions, which means the parabola has two x-intercepts. If the discriminant were to equal 0, in our quadratic formula, what would happen? We'd get solutions negative b plus or minus the square root of 0 all over 2a, and the square root of 0 is just 0. Whether we're adding or subtracting 0, it's still just 0, and so actually we don't get two solutions, we just get one solution, which is negative b on 2a. Okay, so then if the discriminant equals 0, then the equation has one solution, which means the parabola has one x-intercept. Okay, and that is, I'll just summarize that messy bit out there, we actually know what that value is at x equals negative b on 2a. Sorry. If the discriminant's negative, which is what happened in part B, we can't take the square root of a negative value, and so the equation has no solutions, which means the parabola has no x-intercepts. Okay. So again, discriminant helpful, possibly a good idea to calculate the discriminant first. Then if it is positive, you straight away can go straight to this line of working with your quadratic formula. If it isn't, then you don't need to go any further. The other thing I want to do is think about the x-intercepts that we obtain via the quadratic formula more closely. So this is the two x-intercepts, negative b plus or minus square root of b squared minus 4ac all over 2a. Okay. Now we can write that as two separate fractions, so splitting it down the middle here, negative b on 2a plus or minus the square root of b squared minus 4ac on 2a, okay, which is what we've got in the second line there, which means there are two x-intercepts, negative b on 2a plus this fraction, or negative b on 2a minus this fraction, which is what I've got here. So two separate x-intercepts, okay? I want us to think about the common thing about those, okay? We've got a value plus a number, that same value minus a number. So if you think about that, if you're going to plot those points on the x-axis, okay, if this is negative b on 2a here, one of your x-intercepts is at that value plus square root of the discriminant over 2a. The other x-intercept is at that value minus the square root of the discriminant over 2a. So this is one of your x-intercepts, negative b on 2a, plus the square root of your discriminant on 2a, and your other one is at negative b on 2a minus the square root of your discriminant on 2a. So if you think about the symmetry of all that, the only way that happens is if halfway between these two numbers is negative b on 2a. And so that means that we automatically have, our axis of symmetry. So the axis of symmetry, is x equals negative b over 2a. And that means that's the x-coordinate of the turning point. The turning point will have to be somewhere here on this line. So negative b on 2a is really helpful. It gives us our axis of symmetry, hence it gives us the x-coordinate of our turning point. So the format of these solutions tells us that the x-coordinate of the vertex is negative b over 2a, and that the axis of symmetry has equation x equals negative b on 2a. And so it can be quite an efficient way to get to the turning point. Okay, and you might want to use this in conjunction with your other methods. You might still find that factorising to find the x-intercepts is easy, but you might prefer to use negative b on 2a rather than averaging the two x-intercepts to find the x-coordinate of the turning point. Okay, so thinking about, which of my methods is going to be most helpful in this particular example. Okay, so example 2. For each of the following, determine the number of x-intercepts. So that's going to be to do with the discriminant. Okay, the equation of the axis of symmetry. So axis of symmetry is x equals negative b on 2a, and hence the coordinates of the turning point. Okay, so it's not asking us to find the x-intercepts. So number of x-intercepts, let's focus on the discriminant. So discriminant here is b squared, so negative 3 squared, minus 4 times a, which is 1, and times c, which is negative 4. So we've got 9 plus 16, and so the discriminant is 25. It's positive, so we have 2 x-intercepts. Okay, so that's the first part. Number of the x-intercepts. Number of x-intercepts is going to be 2. Find the equation of the axis of symmetry. So the axis of symmetry will be when x equals negative b over 2a. So in this instance, that will be positive 3 over 2 times 1. So 3 over 2. Okay, that's the axis of symmetry. Let me just note what I'm doing there. Okay, so x equals negative 3 on 2. And then the turning point, we've now got the x-coordinate of the turning point, so we can find the y-coordinate by substituting 3 on 2, x equals 3 on 2 into the equation. So 3 on 2 squared minus 3 times 3 on 2 minus 4. So that is 9 on 4. Take away 9 on 2 minus 4. Let's get a common denominator. 9 on 4 minus 18 on 4 minus 16 on 4. So that is negative 9 on 4 minus 16, so minus 25 on 4. Okay, so the turning point has coordinates of 3 on 2, negative 25 on 4. Turning point, axis of symmetry, and 2 x-intercepts. Okay, part B. Let's find our discriminant first for the number of x-intercepts. So b squared, which is 4 squared, minus 2 times a, which is 2, times c, which is 9. So we're going to have 16 minus 4 times 9, which is 36. So we have negative 20. So discriminant is negative. So we have no x-intercepts. So if you've got no x-intercepts, thinking about the previous video where we used the x-intercepts to find the turning point, if you've got no x-intercepts, you're not going to be able to find the turning point. So you could complete the square and get it to turning point form, but actually we now have, using negative b on 2a, we have another way that we can get to the turning point. So let's think about our axis of symmetry, which gives our x value of the turning point. Sorry, symmetry. So x equals negative b on 2a, so negative 4 on 2 times 2, so negative 4 on 4, and so negative 1. So our axis of symmetry is x equals negative 1. And then our turning point is going to be when x equals negative 1, what does y equal? So, 2 times negative 1 squared plus 4 times negative 1 plus 9. So that's 2 times positive 1, so that's 2 minus 4 and plus 9. 2 plus 9 is 11, take away 4 is 7. So the turning point has coordinates negative 1, 7. So no x-intercepts, but you've got the turning point at negative 1, 7, and so therefore a sketch at this point is really efficient. Y-intercept, you can see from the equation, is 9. Okay. Alright, part C, same 3 things. Let's first of all calculate our discriminant. B squared, so negative 20 squared, minus 4 times a, which is 2, times c, which is 50. Negative 20 all squared is positive 400. And then we're going to have minus 8 times 50, that's also 400. And so our discriminant is 0. So discriminant equals 0, which means that we have one x-intercept. The only way a parabola has one x-intercept is if the turning point is that x-intercept. And that's why you'll remember we said that the x-intercept was negative b on 2a when we have one of them, but we also know that the axis of symmetry is negative b on 2a. We know that the x-coordinate of the turning point is negative b on 2a, and that's because they're all the same thing if we have just one x-intercept. Okay, so one x-intercept. We then want to calculate our axis of symmetry. So x equals negative b, which is positive 20, on 2 times a, which is 2 times 2. So 20 on 4, which is 5. So our axis of symmetry is x equals 5. And so that's the x-coordinate of the turning point. So x equals 5. Let's find y. So 2 times 5 squared minus 20 times 5 plus 50. So that's 2 times 25, so that's 50, minus 20 times 5 is 100, and then plus 50. 50 plus 50 is 100, and take away 100, so we've got 0. And that makes sense. We knew already that the turning point is the x-intercept. And so actually if we thought a bit about it, we could have straight away got to the fact that the x-intercept is at 5, 0. So if you've got one x-intercept, your turning point will be negative b on 2a, 0, okay, which in this case is 5, 0. All right, over the page. So example 3, sketch the graph showing all key features. All right, so let's think about what do we know immediately looking at this. We can tell the shape of the graph. We can tell it's going to be a happy parabola because of the positive 3x squared. We can tell straight away from the graph what the from the equation what the y-intercept is, because when we let x equals 0, we'll get y equals 5. So 0, 5. So they're the two things that we can tell immediately from a quadratic equation in this form, in this expanded form, whether it's a happy or sad parabola and where the y-intercept is. Now, it's already expanded out, so we're not going to find the turning point first. Let's think about our x-intercepts, therefore. So x-intercepts, we let y equal 0. Right, then we would try and factorise. 3 times 5 is 15. Factors of 15 that add up to 6, they don't exist. So it doesn't factorise, so we'll use the quadratic formula. Let's calculate the discriminant first to see what we need to do. So discriminant we know is b squared minus 4 times a times c. So that is 36 minus 12 times 5 minus 60. Okay, and so that is negative 24. So therefore, we know we're going to have no x-intercepts because the discriminant's negative. So we don't even need to try and find them. We don't need to go back to our quadratic formula at all. We want to therefore think about our turning point. Now, you might think, okay, I need to complete the square to get my turning point because I don't have any x-intercepts, but remembering the x value of our turning point is at negative b on 2a. So for this quadratic, that is positive 6 on 2 times 3, so that's 6 on 6, that's 1. So turning point happens when x equals 1. We sub x equals 1 into our equation. 3 times 1 squared minus 6 times 1 plus 5. So that's 3 minus 6 plus 5, negative 3 plus 5, so positive 2. So our turning point is at 1, 2. Okay, so we've got no x-intercepts, turning point at 1, 2, y-intercept at 0, 5. So we've got enough information to draw in our graph. Actually, sorry, I might just make that 1 a bit further. 1, 2, 3, 4, 5. So 1, 2 is our turning point. 0, 5 is our y-intercept. Let's just have a symmetric point over there just to help us get the shape right. Smooth turning point. Missed it slightly, but that's okay. It was a rough guide. So this is the point 0, 5, the y-intercept, and we've got the turning point. Minimum 2 points, including the turning point, so we've got what we need. Okay, so the work today is from exercise 7E. The questions are listed there. Please complete the work in your exercise book, and the questions you can get from the textbook.